Welcome again, Wildcats. All right, so today we are looking at Thursday, February 2nd, and we're going to solve cube and cube root equations. So if you would, pause the video and update your table of contents. All right, I assume now your table of contents are updated, so let's take a look at our notes. All right, so you know it's on page 52. So now let's take a look. All right, so first let's look at the solving cubic equation steps. Okay, step 1, factor. Now when you factor, you have two options, sum and difference of cubes or by graphing. Okay, step 2, solve. And you're going to solve linear and or the quadratic. Okay, now if in step 1 you can't factor, then you're going to graph to find the solution, and that's right here. So if the equation is not factorable, then you'll graph the equation to find the solution, and that should actually say solutions. And I say solutions because if you're solving cubic, you're going to have 3 solutions, okay? So if you would, pause the video and update your notes, or this part of the notes. All right, now let's look at the notes for solving cube root equation steps. Okay, step 1, isolate the cube root. Step 2, raise both sides of the equation to the power of 3. Step 3, simplify and solve. So if you would, pause the video and update the rest of your notes. All right, I'm assuming at this point your notes are updated, so let's look at the examples. All right, example 1. So step 1, factor. Now, it looks like here that we're going to factor using the difference of cubes. So what you need to do is pause the video and in your notes, find factoring sum and difference of cubes. That should be it. 3. Okay? And then once you found those, write those two formulas right there. Okay? So, example 1. It looks like a difference of cubes, so we know that A is x, B is 2. So, using the difference of cubes formula that you've written down, that's x minus 2 times x squared plus 2x plus 2 squared, which is 4, equals 0. Now, when I write this down, let me just give a kind of a note about what we're doing. I think example 1, example 2, and example 3 are very difficult. Okay, so I'm going to go over all of them in this video. But what I recommend doing is, if you get stuck on one, circle it, watch me work the whole example, but maybe not write everything down, and then in class, ask me to go back over the example so we can talk about it and you can ask questions and I can explain it in a different way that you might understand it better, okay? All right, so now it says step 2, solve. So we're going to set x minus 2 equal to 0, which if we add 2 to both sides, we'll get x equals 2. Okay? Now we're going to set x squared plus 2x plus 4 equal to 0. Now, we could solve this by factoring, but I've done a lot of factoring, so let's just go back and practice the quadratic formula. So, a equals 1, b equals 2, c equals 4. And so then x equals negative 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times 4 divided by 2. So then you get x equals -2 plus or minus the square root of 4 minus 4 times 1 times 4 is -12 divided by 2. All right. Now, that can be written as -2 plus or minus the square root of -4 times 3. Okay. Now, why that's important is because now I'm going to take the square root of each of those separately. Okay. So next, -2 plus or minus the square root of -4 is, because it's the square root of a negative number, it's going to be I. Square root of 4 is 2, so that's 2I times the square root of 3. And that's all divided by 2. So when you divide everything by 2, you get x equals -1 plus I square roots of 3. And x equals -1 minus I square roots of 3. All right, so we would pause the video and finish up example 1. All right, let's now look at example 2. All right, now this one looks like we can factor by grouping. So I see that I can factor out an x squared from the first two terms. So I'm left with x minus 1. And it looks like I can factor out a 2 from both of those terms. So it's plus 2, which leaves me x minus 1 equals 0. Now we know we factor by grouping correctly because we have x minus 1 here. If these aren't the same, then it's not factored by grouping. So because here you're multiplying x squared times x minus 1 and 2 times x minus 1, we can actually write this as x squared plus 2 times x minus 1 equals 0. And that works because if you think about it, I'm still multiplying x squared times x and -1, which I did here, and I'm still multiplying 2 times x and -1, which I'm doing here. Okay? So now you set them each equal to 0, so you get x squared plus 2 equals 0. Subtract 2 from both sides, you get x squared equals -2. Square root both sides. Remember, it's plus or minus. That becomes the power of 1. So you get x equals, the square root of -2 is the square root of plus or minus. So you'll get the x square root of 2i. And x equals negative square root of 2i. All right, so there's two view solutions. But remember, when solving cubics, there's 3 solutions. So now we're going to set x minus 1 equal to 0. Add 1 to both sides. X equals 1. All right, so if you would pause the video and update your example 2 or finish it up. All right, now let's look at example 3. All right, now example 3. It looks like we can factor by grouping, so let's do that. So it looks like I can factor out an x squared from both the first two terms, so you get x plus 2. And it looks like I can factor out a -1 from both terms, so we get 5x plus 6. Now pause for a minute and I want you to think about what you see. All right, I'm hoping you see that this term and this term are not the same, so it's not factorable. All right, now at this point you can open another tab, pause it and open a tab and graph this in Desmos, okay? I don't exactly know yet how to click over myself while recording Desmos. If you do know how to, that'd be very valuable information to have. But I'm just going to graph it on the Inspire. So again, you have two options, but right now I'm just going to do it on the Inspire. So let me grab a calculator and I'll be right back. All right. So on the Inspire, I'm going to go to New Document, No, Add Graph, and I'm going to graph x cubed plus 2x squared minus 5x minus 6. All right. So all you have to do is sketch this graph on your paper. Okay. So to do that, all right, so what you're going to do is draw your x and y axis. Now to sketch, you see how I have, there's 1, 2, 3, there's tick marks, so I'm just going to put out 1, 2, 3 tick marks on the right. I probably need to write 1, 2, 3, 4 on the left, and then I see the graph goes up to about 4 tick marks, so 1, 2, 3, 4. So then I'm just going to follow the curve. So I see it crosses at the second tick mark, goes up to about 4, then comes down to this 1 tick mark. Kind of can't see where it crosses there, and then it comes back up through the second tick mark. Okay, so that's all you have to do when you're graphing. You just basically put the correct tick marks where they go and give a good, pretty approximation. Okay. All right, so we can see now. This is what I need to talk about. Does everyone? I'm hoping you see this set equal to 0. That means when we're solving, we're actually finding the x-intercepts. So our solutions are where it crosses the x-axis. So our solution is here, here, and here. So our solutions are x equals negative 3, x equals negative 1, and x equals 2. Which we know we're correct because remember when solving cubics, there's 3 solutions. Okay, 3 solutions. Whew, that was mentally exhausting. So, like I said, example 1, 2, and 3 are probably the more difficult to grasp and understand. So I completely understand if you want me to go back over those 3 in class. Okay. Now, going from that, I really think examples 4, 5, and 6 are very easy. Okay. All right. So using the steps, it says isolate the cube root. So in this case, to isolate the cube root, we're going to divide both sides by 7. So you get the cube root of 5x minus 7 equals, so 84 divided by 12 is, or I just said it, 84 divided by 7 is 12. Okay. Now we're going to raise both sides by 3. That becomes the power of 1, so you get 5x minus 7 equals 12 cubed, which is 1,728. Add 7 to both sides. I apologize. I don't know why. It's just some of these are blurry right now, but it should be adjusted now. So add 7 to both sides. So 5x equals 1,735. So we added 7. Divide by 5. X equals 347. Now, my question to you, because I don't know this answer. Now, it makes sense when you solve a cubic x cubed, there's 3 solutions. And we see it because if you look at example 3, it crosses the x-axis 3 times. Okay? But the cube root only has 1 solution, and I don't understand why. So if you could figure that out and explain to me that in class, I would greatly appreciate it. All right, let's look at example 5. All right, so we isolate the cube root, so we add 6 to both sides, so we get the cube root x plus 180 equals 6. We cube both sides. That becomes the power of 1. You get x plus 180 equals 6 cubed, which is 216. Subtract 180 from both sides, you get x equals 36. All right, now example 6. All right, so we isolate the cube root. Well, there's not really where to isolate the cube root, so we're going to cube both sides. So, and I think it's important to note is I'm actually going to convert the cube root of x, because remember, the cube root of x is technically x to the 1 power equals x to the 1/3. Okay? So I'm going to rewrite this before. So technically, this is actually x plus 6 to the 1/3, but we're cubing it. And that's technically 2 times x minus 1 to the 1/3 cubed. Okay, well, here the left side makes sense because 3 times 1/3 is 3/3, which becomes to the power of 1. Now here, when you cube something, you multiply this by times itself 3 times. So that's 2 times x minus 1 to the 1/3 times 2x minus 1 to the 1/3 times 2x minus 1 to the 1/3. Okay, just got smushed a little bit there, but what I want you to see is, first of all, this the 1 power, that's just written as x plus 6. But what I want you to see is when you, first of all, 2 times 2 times 2 is 8. And then here, when you multiply exponents, you add them. So 1/3 plus 1/3 plus 1/3 is actually x minus 1 to the 3/3, which we know 3 divided by 3 is 1. So this is x plus 6 equals 8 times x minus 1. Okay, now you just distribute the 8, so you get x plus 6 equals 8x minus 8. We're going to add 8 to both sides. And then we're going to subtract 1x from both sides. And watch what happens. It's pretty cool. Those cancel. 8 plus 6 is 14. Those cancel. 8x minus 1x is 7x. Divide by 7. X equals 2. Wow, that was mentally exhausting. How about y'all? All right. So, again, very, very important. Now, take some time to reflect and then think about which examples you really want me to go over in class. And I'll go back over them in more detail if you like. But with that, have an Oreo-rific Wildcat day.